In this video, we're going to look at using the calculator to find ratios and angles. So the first one is straightforward. Could you use the calculator to find sine 48 correct to 4 decimal places? Well, let me just type it into the calculator. Exactly what you see, sine 48. Make sure the calculator is set in degrees and not in radians. There'll be a DEG written. So sine 48 is minus 0.7683 to 4 decimal places. Cos 74 is 0.1717 to 4 decimal places. We type in tan 15 and we get minus 0.8559. Now this is an unusual one. I've written down 5 places here because when you round off the 4th place, the 9 here, it rounds up again. So we have to actually round up twice. So it becomes 0.8560 if you want, or 856. Again, I hope you're trying these now with your own calculator as we're doing them. If you type in sine 72 degrees, it gives you 0.2538. Again, the calculator must be in degrees. And lastly, cos 28.5. When you type this into the calculator, it'll give the answer minus 0.9746 degrees. So maybe practice these yourself, see that to work for you. Now this is a more interesting question. Okay, if sine A is 0.6, could you work out what the angle is? Now when we're working out the angle, we'd always use sine or cos or tan inverse. So if A is 0.6, it follows from this, that's what that arrow means, that A is equal to sine inverse of 0.6. And this is what we type into the calculator. Second function sine will give us a sine inverse, 0.6, and close your bracket at the end. When you type that in, it gives you the answer 36.9 degrees to 1 decimal place. So if cos A is 0.7534, well then A is equal to cos inverse 0.7534. So again, we always use the inverse function when we're finding an angle. So type this into the calculator, second function cos 0.7534. And when you do, see you get the same answer as me. It's 41.1 degrees to 1 decimal place. Again, if tan A is 3.84, this means that the angle A is tan inverse 3.84. We always use the inverse when we're finding an angle in trigonometry. So we type exactly this into the calculator. We know we're right, it'll look like this, close your brackets and all. And the answer is 75.4 degrees. Make sure again your calculator is in degrees and not in radians. So there's a little DEG or D in the calculator. Last one, if cos A is 0.2715, well A is cos inverse 0.2715 because we always use the inverse function when we're finding an angle. And this works out to be 74.2 degrees. This is an important example. Okay, example 3. Now here we're to work out from this diagram what is angle A. Now the first thing we'd always do is label, if you could, label the sides of the triangle. In my first question, the opposite and hypotenuse are the sides given to us. Now let's write down SOHCAHTOA and choose which of these SOHCAHTOA has opposite and hypotenuse, and we see it's sine. So we're going to use the sine of the angle A is opposite, which is 6/10. Now this is like the question we had a second ago. So to find the angle we always use inverse, so A is the sine inverse of 6/10. Type this into the calculator. Second function sine 6/10, and it works out to the nearest degree as 37 degrees. Okay, it's always the same method. We'll label our sides. Compared to B, we have our adjacent hypotenuse. We see this time cos is a sensible thing to use because that's the ratio with adjacent hypotenuse. So cos B is 3/8. So B is cos inverse 3/8 because we always use the inverse function when we're finding an angle. So just type that into the calculator, and to the nearest degree that's 68 degrees. Okay, the last one, you should have an idea what to do now. We label our sides. We choose which formula to use with opposite and adjacent. This would be tan. So tan of the angle C is opposite over adjacent, 4 over 5. Our C equals tan inverse 4 over 5, because we always use inverse when we're finding an angle. We type this into the calculator, and to the nearest degree that's 39 degrees. Important to be able to do that. Okay, here's kind of a project mathsy type question. Now, even if you ignore the writing here and just look at the picture, the triangle in the picture is what we're interested in. Compared to the angle x, the 12 meters would be the opposite side, the 30 meters is the adjacent side, and we're obviously meant to find what x is, so we're trying to find the angle. So we choose which of our formula has opposite and adjacent, and it's tan. So tan of the angle x is opposite over adjacent, which is 12 over 30. To find an angle, we always use inverse. X is tan inverse 12 over 30. And just type this exactly like that into the calculator. Second function tan 12 over 30. And to the nearest degree, it's 22 degrees.